Lesson 3.7, Translations. We're going to discuss what translations are by just picking a three-letter word and using it to demonstrate the following concepts. I'll pick the word saw. Simple to draw. We're going to reflect it across this line. That means like if we could fold the computer screen on top and it was wet ink, we would see this. Notice the W and A don't look different because they are symmetrical letters for reflection. The S does it, flips across, so everything reflects across. We could also take the word saw and reflect it like that across that line. Kind of like if you had a big SAW sitting up in front of a pond and you looked at it from the other side of the pond. That's what you would see. So that's reflection. Rotation, if we take the word saw and we give a point here and we reflect it around that point, looks exactly the same. It's just been spun. Actually, the point would probably be more like here, which is fine. And dilation, which is also from a point. Take saw and we dilate it. It's 2 times bigger and 2 times further from the point. And that's this point here. So those are what we call transformations. All of these are transformations. We can take points and move them around. We take words and letters and shapes. That's how they make all the Pixar movies. They transform points and move them around. And the one we're doing today, a translation. If we took saw and just move the whole thing up and over. So it cannot flip, cannot rotate, doesn't expand or contract. I showed you all of those, but translation is just a simple move. Up and over, slide straight across, slide down. That's it. So we're just focusing on translating things, and the best way to do it is to do it with points on a coordinate plane. This is the point -2, 4. This is the point -1, 1. This is the point 1, 3. We have a shape, looks like this. And let's translate it. Let's translate it over 5. 1, 2, 3, 4, 5, and up 2. 1, 2. We get right in the middle of our point here, so I'm going to relabel this one so it's not in the way. This is 1, 3. So here's our new shape. Notice it looks exactly the same. Just been moved over. And each one was moved over 5 and up 2. So finding the point is pretty easy. I just read them off the coordinate plane. I don't really even try and mess with what's going on. Be 5. That's it. Now, why translation at the end of parallel and perpendicular lines? Because it's an application. These are all parallel lines. So we're just using parallel lines to move something. An application of geometry. So now, just moving one point in the interest of time. Move it here. So this point is 1, 2. So let's get all the way down here. -4 comma -3, and we go all the way up to here. That is 7 comma 7. So we write it like this: x comma y translates to x plus 11, y plus 10. -4 plus 11 is 7. -3 plus 10 is 7. That is how we write it with an ordered pair. So try one more, and I would do this on your own. Translate these points as I've told you to do up here. Pause the recording if you want. Now I'm going to do it. I'm a big believer in labeling. Actually, I'm going to label them later because I'm worried I'm going to get in the way. But there it is. This was 1 comma 2. Moved over to become 4 comma 0. This was 2 comma -2. And it went over to become 5 comma -4. This is now 1 comma -4, and it was -2 comma -2. 3 over, 2 down, 3 over, 2 down, 3 over, 2 down. That's it. A little bit tricky, but not too bad to work on, so give it a shot. Good luck.